Tethered microphone. Can you hear me? Good. All right. Awesome. All right. Ali, thank you. And I'm glad to be here. This says you guys are like in a bunker or something here. This is odd. I was trying to find my place. So, I was kind of interested in you as students. Are there system engineering students here?
Plus, it's systems engineering, so
Systems engineering, software development, computer science. Okay. And then, oh, industrial engineering. Nice, nice. Good, good, good. Well, I want to tell you today about a couple things, and hopefully you're interested in them. Ali asked me to come speak to you, and I wanted to talk to you about INCOSE. INCOSE, the International Council on Systems Engineering, is one of those associations you might consider as you look forward into your professional careers. And then it's kind of timely because just last weekend, INCOSE held their international workshop, and it was over in Torrance, California. I think it gives you, and I got slides to cover that activity that went on there, and I think you'll be interested in what INCOSE is viewing as societal needs for systems engineering and the kinds of projects and the kinds of interactions that we think about with complex systems, complex socio-technical systems that you will be facing as you enter into your professional careers and industry. And then I've got a couple of slides on Prime Solutions Group, which is my company. We are in the West Valley, so it's about a 45-minute drive for me over here this morning with the traffic and all. But we do some very high-end defense work in intelligence, surveillance, reconnaissance. We take censored data that comes from all different kinds of sources, airborne, spaceborne, and then other types of data that you might get. You've seen things about social media data. Those kind of things can all be fused together for an intelligence view of the operational picture. So I've got a few slides on that. But will I change the slides here? I'll change the slides here. It looks like, oh, maybe I just hit down. Okay.
you're comfortable with this one.
Oh,
These are pointer.
Yeah.
So you can just put this.
nice. Oh, maybe.
So
That way. Okay. All right, good. So I have I have a set of slides here, and I want to tell you about these INCOSE activities, and I hope they're interesting. They're interesting to me. I sat in your chair many years ago, graduated from Arizona State University, and went into the United States Air Force, where I spent a career in space systems. And so I was just thinking, driving over here, what was I thinking when I was sitting in your seat? And there's a lot of uncertainty. What am I going to do? How am I going to do it? Now, I was destined to go in the military, but even that had a lot of uncertainty. And what kind of jobs will I be doing? So I kind of have some recollection of where you might be going. I'm hoping some of these slides cover some topics about that. Um, you can ask me questions anytime, anytime. And if this stuff isn't so interesting, we can talk otherwise. So, but again, I want to tell you a little bit about INCOSE. It's a professional society, and it promotes international collaboration around the world for the practice of engineering, the discipline of engineering, and it's systems engineering. So I think that means industrial engineering to you industrial engineering students. I also think it means computer science. I also think it means um, the other well-known engineering disciplines, but it's how we think about problems that we're trying to address, and then the what that we're going to use to solve those problems, and a lot of it is about systems thinking and how we think about problems. What are you trying to do? And then B, how and what are you going to use to solve those problems? And so, big systems engineering network, you can see some numbers up here. I've been involved with INCOSE since probably around 2007. Um, when I really got involved, and I've been involved since in a variety of capacities, and I'll cover those as we go. This slide didn't tell you anything, so it was one of my mission. But here's the mission and vision for INCOSE to unite an advanced global systems community, which is large and growing as you look at the complexities of systems throughout many domains, defense, aerospace, healthcare, automotive. There are some very complex problems that this body unites around and tries to look at how are we going to solve the next challenge. And you can read the mission there. Forums, and I mentioned that I just came from the international workshop um, in California, and again, I've got some slides to cover that. Here's a vision for systems engineering 2035. So again, as you're sitting there thinking, well, what am I likely going to bounce into as far as careers and career choices, and what are the challenges? This Vision 2035, there was a 2025 as well, which actually did pretty good in terms of predicting where we were going to be. But this 2035, and you can go download this. It talks about the context, the state, the future state, and then how do we get there? This is a little marketing stuff, but here's some of the member benefits. I borrowed these slides. So it's a global network. You can be certified, and myself, I'm an expert systems engineering professional, but there's a whole series of certifications you can get. Lots of material in terms of publications, a systems engineering handbook, and you can read all these other things. I did want to mention this. There's a Technical Leadership Institute within COSE, and it is really looking at how do we work with young professionals and people entering the field of systems and industrial engineering. And this program gives people access to mentors from around the world. So you can be talking to somebody in Germany about their experiences, and so it's a very good program. I've had one person go through that. an ASU grad, by the way. And he had a desire to get into financial systems. And he took a lot of what he learned here and then moved on into financial systems. So, and then there's a mentoring service. So you get a lot of access to professionals who have been in their domains for, in some cases, careers, and it can be very helpful to you. I mentioned the certification business, systems engineering professional certification. Over here on the left is kind of a beginning certification. And then there's a certified system engineering professional or some years of experience. And then ESEP, now what? Now, oh, okay, this is the next slide. So this is just some data on the people who are certified through INCOSE and the numbers. This is becoming a very important thing in industry, particularly in the defense industry where I come from. Many of the defense industry giants are touting the numbers of certified engineers they have. It helps them with recruiting new engineers, and it also helps them with explaining to their customers what they do and how seriously they take the engineering profession to build things for, say, the government. Okay, now Career Center stuff there. This is all stuff. You go to incose.org. You can find this kind of stuff. And you guys are seniors. You're going to be looking for work. You're going to be looking for work. So here's a place where you can go and look for opportunities. Many of the big dogs publish their open positions here. So take a look at it if you're interested. At career fairs, we've participated in a couple of the career fairs. So mark this one as an area to go look at. And so I mentioned the international workshop, and it was just last weekend. I forget, 400 and some people in person, virtual participation from around the world. And really the goal is to look at what we can do to advance the art and discipline of engineering, particularly systems engineering. And then there's a once a year international symposium that is usually in the summertime. This summer over in Japan, and I'll be going. I need a new Grand Seiko, so I'll buy it when I'm over there. Those are the two big sessions. So here's just some summary stuff I pulled from the workshop this last weekend, and just to show you the kind of problems that get teed up and evaluated and looked at. It's called this project's called Project Wildfire, and it has a use case built around a wildfire event that happened sometime in Oregon a few years back. And so INCOSE at large took this. There was some really tough lessons learned out of this particular wildfire event, and really had to do with emergency management and the continuum there. And then you can see the other areas that got looked at. And this is kind of how do we think about this? How do we think about the problems? How do we think about the challenges? And then what would we do to solve those challenges? And so I just kind of go through a few things here. Explore the application of systems engineering to a community mission-driven capability, which was this response to this wildfire. And so the focus has been on, and this has been going on for a year, this project. And the scenario was this holiday farm fire. I think it was in Oregon when it happened. And it's really looking at how do you look at a system engineering approach to design an effective, does my pointer work? An effective mission engineering outcome for this emergency management continuum that it was called. And so, it brings in ideas like system of systems. How do I make decisions? Model-based systems engineering. Does that ring a bell with anybody? Model-based work. So start thinking about that, because when you go to your new employer, they're going to ask you, which model-based tools are you familiar with? And here's ours. So you need to get brought up to speed on whatever tool environment you might go into. And then, of course, the artificial intelligence, big stuff. I don't think I have to tell you guys, it's come in with a vengeance. It's all over the engineering world. It's part of solutions. It's how we are trying to solve problems from the whole supply chain. And of course, you all are going to be immersed in that. So real stuff. People participating in this. So part of this activity was, who are those users? Who are the stakeholders? And how do we go understand their concerns? How do we understand their capability needs from an architecture perspective, from a system of systems perspective? I mean, you have a lot going on. You got communications, RF communications, you got vehicles and people, you got health, you got medical. So you have a lot of stakeholders. And the emphasis here on mission is really something that you run into from the perspective of what is the capability? What are you trying to do? And that's what the systems engineering world gets challenged with a lot. What is the capability that we need? And you find out that there's a lot of aspects to that. There's going to be different domains involved. There's going to be stakeholders all the way from the customer down to operators, down to users. In this case, the people that are driving emergency vehicles. So the mission engineering is really a part of systems engineering, because when we think about it, if we're not supporting a mission, what are we doing? So, did that answer the question? Yeah. So, but this is a perspective that that a lot of people have now in engineering as to what are you trying to achieve? What are you trying to do? So, so I mentioned the AI parts. So, INCOSE as a professional society is up to our elbows in this. And it's a safe environment to be thinking about it and talking with other professionals about what they're doing with AI, how they're doing. how they're using it. Here's the mission engineering again. And then this notation, SysML, which is the basis of model-based systems engineering. How are we communicating that, and what's the notation we are using to communicate it amongst other professionals? AFSIM is a simulation capability. But a lot of stuff on this slide. But really, how can we then use AI in this case, in this wildfire model, to help us come up with some of the mission engineering solutions that should have been considered, or for the next emergency, how would you prepare for it? So this is just some takeaways of that wildfire scenario. And so here's something that we're learning in the systems engineering world, is that there's a lot of interest in how do we apply the systems engineering, systems thinking to really complex and broad socio-technical systems. And you can think about all of that. This is example of a emergency response, but everything from self-driving cars to hypersonic vehicles to undersea exploration, deep sea exploration. All these things require some thinking and some new ways of posing the problems so that we have a better chance of solving them. And again, this mission engineering, I'm glad you asked the question, Ali, because it's very important in my domain of defense. That is the number one thing. If you're not building new capability for a warfighter, then you don't belong here. And so these are the themes and the messages that are coming over and over. There are some next steps here. This will continue on. There was some other summary stuff. Again, AI and systems approaches to autonomy. I mean, that's the name of the game today, right? Autonomous systems. How can these things work for us? And how can systems assist us with what we're doing? Maybe not take over for us. Who knows? Maybe what's that called? There's something about when machines become smarter than us. I don't know if we're there or not, but and then a lot of thinking and a lot of discussion, a lot of work in what is the future of systems engineering? What does it look like? And so it goes across. Already kind of mentioned these type of challenges that are out there: resiliency, adaptability, and then what are the new capabilities and tools and environments that we're going to need to solve some of these complex challenges? And then what are the insights and needs for a future of systems engineering? So that this is a big part of what goes on. And then it's kind of summarizing here the AI and autonomy applications. So a lot of things to consider. And a lot of things to consider in industry, professional societies. So there's a lot of work here. And it's not just in INCOSE, it's at IEEE. And then there's a student division of here. Correct. So that I'm sure that group is deep into these kind of things. And
I just started like 1 year ago, so late stepping. But
okay. Well, I want to talk to you about maybe an INCOSE student division. So teamed up, so you get the benefits of both. We actually have we have a active chapter here in central Arizona, and there's also an active chapter of INCOSE in southern Arizona. Correct. Yeah. So anyway, we can talk about that. So again, AI and autonomy, it needs to be part of your preparation as you go into industry, because in just about any industry you go in, they're going to be working towards these kinds of capabilities. So, using Chat GPT to figure out where to go to dinner is the same chat that they're using to produce complex proposals for complex systems. So let me keep going here. Again, this is kind of the question that everybody ponders: can we build these systems, and how will they be trusted? How will we verify them? How will we use them? How will we train them as we deploy them in some kind of operational environment? And then, of course, at the end of the day, um, who's responsible? Are we going to be responsible as engineers for the outcomes that these systems produce? Another breakout group here, integration and interoperability, trust and human AI teaming. I mean, go down this list, you can see that these things would be big questions as we start thinking about putting AI into the hands of operators.
A lot of the focusing on how we bring AI, right?
Correct.
Their conversations or topics given to the idea of, okay, well, this is not a standalone product. Other people, including adversaries, are going to be able to have access to AI systems.
Right.
And how do we, with our increased reliance on AI, also take that into account, that are we making ourselves more vulnerable with our over reliance as a solution set?
Yeah.
Was that brought up at all, or?
Oh yeah.
Okay.
Yeah. I mean, this idea of vulnerability, resiliency, how can we operate through, even though we might have an adversarial attack on us? How do we then continue to trust the AI as you go forward? So a lot of very, very fundamental questions on how will we use it. How can we continue to trust it? And there's a lot of thinking now. Again, my experience with defense is they talk about the wingman, the AI assistant, and there's always a human on the loop. There's always somebody who's, until they get comfortable enough, say, okay, let it go. There's always somebody, and there's a lot of information coming from a lot of different sources to inform decision makers on, is this right? Should I do this? Well, what are the options? And the AI has just been there pumping out potential solutions, not implementing them, counting on the human to make the decision. Yeah. But these are the whole, all of these topics fall into what you were asking about, right? How you gonna validate it, and how you continuously validate it. If it needs to have new training, how do you then train it? Do you train it in line with operations, or do you have to take it off? And so, a lot of real heady questions that you guys are going to get to solve.
I'm not responsible. The AI came up with it. Is
That's
it
right.
Commander that's going to accept that responsibility, or are we all going to throw our hands up?
Correct. Yeah, I know. I mean, I see it even at my level in our defense small business in the supply chain. I've got engineers who want to use AI and large language models to develop things. And And that's good. But when you look at it, man, there's some hallucination here. I don't know why we'd even talk about this under that topic. So yeah, be careful about that. So I'm sure you guys have bumped into this using AI in your coursework and stuff. And how do you get through that? And how do you use it where it's useful to you? And but yet not let it get you into corners where you shouldn't be. So, any rate, great question. Now, so standards, did I run out of juice here? Here's my favorite slide. This one, so I mentioned I've been in INCOSE for a long time. I think 2007, I went to my first international workshop over in San Diego, and I said, man, this is a place for me. I'm going to be here, and I have been ever since. My career experience in space systems had shown that there's a lot of big challenges, and fundamentally, a lot of times it was, man, we didn't have the requirements right. We didn't get the requirements right, and that's why that satellite is in the bottom of the ocean right now. And so, just having a lot of emotions over that. I said, this is the group that's figuring out how we're going to be able to proceed and address these complex. But so standards. Along about 2010, I was in one of these working groups, and I was working on a small business systems engineering standard. In other words, how does the small business consume a ISO standard like 15288, which is the systems lifecycle standard? Too much, So I was working on condensing that down into bite-sized chunks that small businesses could use. And I got involved with that, and one thing leads to another. Volunteer societies, right? You end up with volunteer jobs. But I am now, as of last weekend, the assistant deputy for standards development at INCOSE. And in that capacity, I work with ISO, IEC, the International Standards Organization. Anybody ever heard of that? Seen those ISO standards? OMG, the Object Management Group. Anybody? IEEE, AIAA. So many organizations that are involved in standards. And this is an important area, and it should be an area that you look at, pay attention, because what standards try to do is to normalize processes and procedures that industry should use for a variety of different things. And the reason you do that is for international trade. I mean, if we build cell phones differently here in the US than they do in the UK, when you go there, your cell phone don't work. And so those are the kinds of things that these standards do for us. They help with the international economic trade and environment. So, but then there's many other parts of standards that allow you to look at your particular industry and what are the best practices and tools in the industry that you might go to. And then, of course, a lot of confluence here with academia. And then, of course, your customers, in this case, saying the government, are going to have a lot of constraints and regulations and standards that you are going to have to comply with. So very, very important, very critical. Something you want to pay attention to. On top of the growing sense of concern that the standards can tell you the what, but they can't tell you the why and the how. That's what you're going to have in your quiver about. That's what it says. How and why am I going to do that? And there's that systems thinking that you're going to want to develop, you're going to want to think about, because you're not going to always cases be able to ask ChatGPT, what's the solution here? You're going to have to think through it. You have to think through it with people who are your peers, people who are stakeholders, people who are bosses, customers who are asking for solutions to hard problems. So think about standards. I don't know if you get much exposure to those. And
Yes, sir. I wanted to ask, how do standards, yes, I wanted to ask on how could standards be flexible enough to promote innovation while still being strict enough to ensure consistency? Like, I'm trying to understand the balance between them.
well, so that's a part of this thinking. You have to tailor standards for your own environment and your own use, your own industry. And you want to tailor them in such a way that you're still compliant with your stakeholders and your industry. I mean, if you're making steel beams and you're making them different than they do in Canada or Japan, you're probably going to run into problems. So you may not have to use the same ingredient recipe for pulling those beams, but they better be the same size, because if they're not, somebody's going to be in trouble. So kind of a tongue-in-cheek answer to your question, but it really gets back to, you have to look at those standards and you have to decide on which parts of those standards that are applicable to what you're trying to do. And a lot of times in industry, you'll get policies and procedures that are derived from standards, that they're pulled out the salient pieces that you need to pay attention to. But again, back to you really have to think through what parts of standards are you going to use and do you need to use in order to be competitive, in order to be relevant in your domain. So at any rate, probably spent enough time on this one, but standards are near and dear to my heart. It's an interesting community when you start getting into international standards. I was at the ISO plenary of the subcommittee 7 last year in Bangkok, and we looked around, and there's a lot of people with no hair, gray hair, and so there's a huge objective to get young people involved in standards. And so, when you look at this stuff doesn't make any sense. We need to fix this. You really have opportunities and a voice to get involved internationally with how these standards go. I also mentioned OMG. That's where we got the systems markup modeling language derived from UML. That's been an ongoing project since 2017 to get to our latest version. And you would have the opportunity to work in something like that. So you don't have to end up taking what they give you. You can make it more relevant, more useful to you and what you think you're going to need in your careers. So think about that. Standards are a good place for anybody, but certainly early career types to get involved with. It will propel you very quickly into your domain, very quickly. So, all right, enough there. I said I'd talk a little bit. it's 45 minutes. All right. Well, I'm perfect here because I wanted to end with a little bit. That's my INCOSE pitch. So I wanted to tell you a little bit about Prime Solutions Group, my company. I started this company in 2007 after a career in the Air Force working on space systems, all the way from Atlas through the shuttle, and then to the United Launch Alliance. So I was involved with all that. I worked on several different satellite systems for international communications, GPS worked on, and then I got into um, intelligence, surveillance, reconnaissance, and so that gets you off into a so-called black world very quickly, classified work, and so I had been in that. When it came time, I was at the Pentagon. Came time to retire, and said, "Well, where am I going to go?" Um, and I wanted to go to California because I'd been there for 10 years. And my wife said, "No, there's earthquakes there." And so I said, "Okay, well, how about we go back to where I'm from, Arizona?" And so I went to work for a company out in Goodyear, in the far West Valley here. It was called Loral Defense Systems, and they built synthetic aperture radar. And in fact, the patent for synthetic aperture radar, does that mean anything to anybody? It's a sensing modality for radars. But that had been created there. I had, in this black world, I had had some exposure and work in synthetic aperture radar. And so I was able to get a job here in Goodyear. And I did that for 10 years. And then I had one of my military bosses call me one day, it was like 2004, and he said, "Hey, we're going to get the band back together and we're going to build space-based radar." All right, boss, where do I show up? So I ended up back over in California working on that. And that was a few years. And there's been a lot of history about space-based anything, but particularly what we were pitching was proliferated constellations of these sensors, which didn't go very far back in that time. Now it's all the rage. It's what they're doing. But at any rate, I did that for a while, and then in doing that, I ran across people that I had worked with at the Pentagon and blah blah. And I said, "Hey, we could use your help." And so I started this company, Prime Solutions Group, which was a contracting center for me. And I did that for a few years, and then out in Goodyear, which had now become Lockheed Martin, they bought Loral Defense Systems. They announced that they were closing. They're closing their facility out in Goodyear, and so I was there. I was doing some work with those guys, and I finally said, "Okay, must suck to be you. Your customers leaving." And, yeah, yeah, made a go of it. But at any rate, it didn't turn out that way because Lockheed Martin closed, and many of the people I had worked with over 10 years on programs there at Lockheed either wouldn't or couldn't move to the places that Lockheed wanted to send them. And so they call me up and they say, "Hey, can we put Lewis and Fred and Dave on your contract? And it'll only be for 6 months as we transition out of Arizona." I said, "Okay, I'll do it." So we did it. And like I say, that was 2014 by this point. And so 6 months turned into 9 months, a year, 2 years, more contracts. And so now Prime Solutions Group occupies some of the vacated buildings out there. Does anybody know where I'm talking about? Out at the Phoenix Goodyear Airport? Yeah, so we occupy some of the vacated buildings that Lockheed Martin left, and we do classified defense work out of this. But here's just a picture of what we think our mission, our mission solutions. They're not software solutions, they're not engineering or industrial, they're mission solutions, as we were just talking. So we still work in SAR systems, AI, as I tell you, intelligent sense making. This is all about AI work that we do. And then enterprise mission services, cloud DevSecOps, cloud development. In our world, a lot of what the government used to buy as compute centers and put in bunkers like this, they want to put it in the cloud. And so we do a lot of that kind of work. But this is what we do. We have several programs. We work with university. I'm here today with you. We also are members of SINSIP, Sensors, Signals, and Information Processing Consortium over in the Goldwater building. I think it's in the Double E department. So that's near and dear to our heart. Pro tech associations, INCOSE. How do you continue to get exposure to your domain, your world, other domains, professional technical societies? And I would encourage all of you, as you start getting out into your careers, think about that. Doctors belong to their medical association. Dentists belong to their association. As an engineer, you should belong to a professional association that you identify with. So I would encourage you to do that. R&D, digital engineering. Engineering now is model-based. There are no documents. We do a lot of work with a lot of industry, defense, industry base, and we don't send anything by mail. It's all digital. We share models. They ask us to respond in model speak for questions they have for us and requests for proposals. So model-based. And so this is a big piece of what we continually do to try to get to that digital transformation that you've probably heard about. All the industries you're going to be looking at are doing the same thing. So think about that and get smart with that, because you're going to want to respond to those kind of questions. So anyway, that's us. I mentioned this synthetic aperture radar business. Well, this is it's a snap of synthetic aperture radar picture. And so there's a lot of stuff in this picture. Synthetic aperture radar builds a huge aperture by transversing lots of space like you can do on orbit. And when you get that data back, you can resolve it into, some people call this blobology, but it's a radar signal. And so we do that. And these pictures are part of our AI, because when you look at that, that's something hard to tell by human eyes, but a machine can pick that out immediately, tell you what it is. So there's so here's some blow up of that. That is an aircraft, a Russian aircraft. That is one that's moving. And so these kind of signatures are important for an intelligence analyst for for the human eye. The untrained eye, we can't tell what this is, but again, that human and then that human assistant can go through something like this and say TU-95, bear, you know, all these things and give that analyst that that leg up on assistance from a machine perspective. So, guys, I think I have more pictures. So I just leave you with maybe a question. You know, where are you on your journey? You already know that complexity is all around us, and I've mentioned this how and why. So you want to think about that. There's going to be no easy answers when you get into industry. There are very difficult problems that are trying to be solved today. And so the more you can prepare yourself for this how and why, the better off you're going to be. And so that's my contact info, and I guess I can take your questions. Did we get done in time? I got 10 minutes for questions. Thanks for listening to me, guys.
So one of my questions was, as a systems engineer, you think different. So the systems thinking. So for like a fresher coming right out of college, right, getting into this concept of system thinking, what made system thinking easier to understand for you? Or like what made your brain kind of think in systems thinking?
You know, there's a saying in industry, particularly in defense industry, you can't teach systems engineering to students. That's being rebuked quite a bit. Here you are in a systems engineering class, so you can learn systems engineering. You know, to your question, I really think it's more about you know, what is your passion? How do you want to address problems? How do you want to own problems? How do you want to understand everything about them? Which then gets you to, I got a boundary and I need to understand all this, but I probably should understand a little bit about that. And it's that, I think it's that curiosity. It's that, you know, you're going to launch a space shuttle. What? What does that mean? So, you know, if you have that kind of curiosity, and you obviously do, because you're sitting here in this class that's talking about the systems thinking domain, keep that up. Always be curious. Always be asking. Again, always be thinking about, okay, there's no prescribed answer here. What are we trying to do, and how are we trying to do it, and then the why. You know, back to that. There's standards discussion. There's you know, you guys are going to go into places where there's a lot of information that's going to be at your fingertips. How are you going to use that information to make your bosses happy? And you got to be thinking about that. I don't know if that answered the question. Keep that curiosity up and always be thinking. I have a lot of software engineers that work for me and love them to death. But they don't think systems wise. They want, give me the features, give me what you need, and I'll start coding today. And they're great at it. But not really thinking about the extended circumstances. Oh, I want to put a machine learning algorithm into this. And it's going to now have additional inputs from other sensors. And so, you know, how is that going to work? And what does that information look like? What are the formats? So, you know, it's just that kind of thing. It's a little different mindset. But keep that curiosity up, and it's going to pay off.
So I have two questions. First one is easy. How many engineers you have, or what is the total number in your company, and how many of them are engineers? That's one.
Okay,
The second one is you mentioned your career and, your life, different adventures happening, your friends calling, your boss calling. It looks like not a really planned life, which I really liked it. What would you recommend these young, bright engineers like to get out of your experience? Like, was it a good one? What do you recommend them? Like, it looks like you didn't have a job and did it 40 years or 30 years.
yeah,
You changed a lot and kind of sporadic, some luck, some coincidence,
yeah, there's
and a lot of
yeah,
preparation probably.
correct, yeah.
So 2 questions. Thank
Well,
you.
okay, so 2 questions. My company has 55 people. About 30 of them are engineers of some kind. I mentioned we have a lot of software engineering. The rest of them are systems engineers like me, or architects, because we do work in defense and those problems come down. Hey, I've got a command and control issue, and I want to be able to provide information at the edge for this particular mission. How are you going to do it? And you got to, think architecturally about it, and then think about, well, how can we do this in a creative way with innovations? Kind of talked about that. So, takes teamed up people. I mean, I can go build it, but you got to let me know what you want built. And then on the career question, gosh, I mentioned I'd sat in your chair once upon a time, and I've talked about curiosity. Get prepared. Finish your work, get your degree. It's going, I don't have to tell you guys, it's hard. There's a lot of expectations. Prepare yourself because the expectations get harder and harder and harder. So what you're doing is spot on. You have a bright, bright future. Stick with it. Understand what you can learn here. I'm sure you've heard it in the past. A career in engineering is a continuous learning. So as you, and it's not just the coursework, right? When you get into industry, they're going to say, hey, we use these tools. Well, you're going to go figure that out. Oh, hey, we're doing some Python. Got to know Python. Job, you've got to be able to talk across those domains. Otherwise, you're not going to be as effective as you could be. But keep that curiosity up. Always look forward. Be positive. Build relationships. Join your desired professional, technical association. Get involved. Jump into things. Standards. Boring. Who's going to do that? Well, I've been all over the world twice just in the last 4 years over standards. And I've met people I'd never would have met otherwise. So just kind of an example. In my case, I had a military career, and that was very good. I just fell into it. I fell into space systems, and back in the time when space systems weren't popular. So now we have a whole command. I'd have been in Space Force, now, but I'm not. I wasn't. So, it's just a matter of there's timing. There's things that are going to happen in your career. Take advantage of them. Reach out, grab opportunities, and pursue them. And you are going to be very, very happy with the results. So, it's going to work.
Hello, sir. Thank you for the talk. I was associated with the defense manufacturing back in India. I was working with Ministry of Defense. I was making Pinaka rockets. And my question is just like, I want to work with systems and governance. So I want to be close associated with the engineering. So what value or skill can you tell me to do next?
You were asking about systems and governance?
Governance, yeah. I worked with the Pinaka rockets manufacturing back in India with the Ministry of Defense.
Okay.
Yeah.
Governance from a industry perspective or
Yeah.
government perspective
Yeah. Just like management thing.
and management?
Yeah.
Uh, what I can tell you is that's going to be a Bible. That's going to be very important for you. You got to pay attention to that. The governance where where you end up in your domain is going to be huge. You have to work within those constraints. Pay attention to it. And don't color outside the lines. It won't work out well. I don't. Did that answer the question?
Yeah, just like when we were just it is a short range missile, Pinaka rockets. Do you heard anything? Pinaka rockets. Pinaka rockets. They are short range missiles where we put in the borders of India. And what we just dealing with the problem is like we have to increase their range, but we are not able to because of the structure and manufacturing. So we failed in documentation, just like we interns. So there we faced a lot of problems. That's why I asked you. the
Yeah,
question.
yeah. Well, and there again, that's where your systems background is going to come in, right? You're going to have to make trades. You're going to have to do decisions analysis. You're going to have to look at architectures, look at designs, look at your capability that you're trying to build, and that's the business of this iterative interaction with customers, stakeholders, government. This is what we can do right now, and here's the risk that we're going to run into otherwise if we're going to try to meet envelope types of requirements, and open communications. I can't tell you how many times when we don't, and you've experienced this in your own lives, when you don't go back and put it on the table and say, this is where we're at, this is why I'm here where I'm at. You usually get a much better result out of that. So I don't know if that answered your question.
Hi, I have a question. You said you started your company in 2007.
Correct.
Did the Great Recession have a role in like any struggles that you had did you have any struggles like starting your company in that recessionary period? And if so, what were they?
Well, yes, it's hard to start a business. It's impossible. You can't do it. And you get told that over and over. You have to have that commitment and that dedication to make it work. And yeah, the recession was a tough. COVID was even worse. We work in a closed, secure environment. Can't come to work. We got to do the work in here. So you got to solve that. So. Business is hard. Business is a challenge. You have to be very focused on what you want your business to do, and then you have to go find the people, mostly the people, that can help you make it come true. Money's always a concern. In my case, I wanted to be in the black all the time. So this company is completely debt free. So there's some thinking there. Don't believe anybody who says you got to go get a big loan to do business. You can start a business and you can bootstrap it up. You can work yourself for a long time, and then you start having some resources where you can add to it. What is your specialty? How do you discriminate yourself from your competitors? And so, thinking about those kind of things all the time. And I showed our mission centers, and I'm guilty of it. Hey, I want to run over here and do this. Boy, that looks pretty cool. Well, no, stay focused, stay on the things that are in your lane, and you're gonna be better off for the long run. So I don't know, a lot of other challenges, but it really is that commitment and that stick-to-itness that you need to have as a business person, with an engineering background, or a business person who's an engineer, so both of them. And systems engineering helped me a lot to think about that. And I mentioned small business system engineering standards. I mentioned things that you can glean from professional societies that you're going to need to turn into revenue.
Perfect, thank you.
I was just gonna ask, for like a company like yours, when you're looking at potential candidates for like a systems engineer, what would be like a couple of attributes and skills that really like set someone apart from, say, like the rest?
Well, so, you're looking for background and some relevant experience. But what I like to think about when I try to impress on my team is I'm looking for potential. I'm looking for potential. And so I don't necessarily care about what you've done in the past. How can you make me make money in the future? And so to the extent you can be very positive and you can throw those kind of ideas out when you're in interviews or discussions, show incentive, show ideas, share thoughts, get involved. And for a person in business, I'm going to pick you every time because this is somebody that's reaching out. This is somebody who's teaming with other people. This is the person I want on my team. So,
Thank you so much for your time.
hey, thanks, guys.
So, okay, if anyone wants to meet you in person, they can come over.
Oh, sure.
Like 5 minutes or so.
Yeah.
Thank you so much.
You're going to be in places where you're going to need a nice suit. Get one. That's that we're gonna. Hey, thanks. Always useful. Thanks.
That was me.
Oh, nice.
So, during, the Air Force.
Oh, no kidding.
Yeah, and I'm on track to fire 28 or 30 years, right?
Okay.
So, like right out that.
Yeah.
You have to transition. That, like, should I get into industry as fast as possible? Should I stick around? That's our late stuff.
Well,
What's your recommendation?
personally,
Yeah.
I still draw a paycheck every month.
Yeah, right, exactly.
And want to, the deal about medical for life is
Not a bad deal.
It's not a bad deal.
Not a bad deal.
But you